Hi, I'm Alan Ross. I'm the managing editor of APC Technologies. We are at the IEEE PES Grid Edge Conference, one of the sponsors of these interviews. Our other sponsors are Dynamic Ratings and H2scan. Enjoy these interviews. So my next guest is Traci Hopkins. Traci and I go a long way back. We've known each other for what now, a decade?
At least.
At least a decade. Traci and I were at one time, when I was the president of the Electric Power Reliability Alliance, Traci was in charge of everything that I wasn't in charge of, right?
That's true.
Which was a lot of things, but I retired, and then Traci has since become the Latin American business development manager for H2scan, which is a company that makes hydrogen monitors. We're going to talk about that in a minute. But the first thing, we were at lunch yesterday, and we were talking about educating the marketplace. Now, with all of the change going on at the grid edge, right? Education of that marketplace is tremendously important. I have asked 4 guests already to define grid edge, so get ready, I'm going to ask you. Every one of them defined it differently, but they were all correct. When I say grid edge, what does that mean to you?
So for me, grid edge is the point at which our current legacy assets no longer support the future of electrification. And we need to develop new products, new procedures, new policies to keep up with everything that's going on in the world today, with the demand that's out there.
Where we need, I love that, because the assets are not, they're aging more rapidly as
Certainly.
a result of the grid edge.
That's right.
We just had a gentleman that was from Pfiffner that was talking about power quality and the impact of an inverter-based system, wind and solar and all that, is having on the existing infrastructure.
Right.
It's aging them much more rapidly than
That's
they
right.
have. So when we were talking about the whole idea of educating the marketplace, you mentioned training. Traci's background for years was in training and education with a company that we both worked for. But one of the things I admired the most about you, you worked at a corporate level. You were able to get like the corporate people to say, okay, let's do a significantly, it wasn't like training an individual, you were training a whole job, the organization, job functions and moving them up there. But so I really respect your knowledge about training, but what specifically do we need to educate through training and education the market on as it relates to hydrogen?
Well, you know, it varies on what market you're in. In the respect of transformers and transformer industry, when it comes to hydrogen, people need to understand that hydrogen is a byproduct of the breakdown of that dielectric fluid inside that transformer. So when something abnormal occurs inside that transformer, hydrogen gas is going to be produced. That's an early indication. Let me step back. Because it's produced at those lower temperatures, it's an early indication that something's going on. You need to get out there and investigate before that becomes a potential catastrophic failure.
Okay. So I would think that IEEE, IEC, SEGRA, you would think that all of these organizations would have made that the case. However, they spent 6 years in the Transformer Committee for IEEE developing the new DGA gas guide.
Right.
So everybody's paying attention to the DGA part of it, the acetylene, the ethylene, the methane. If hydrogen is that important as a signature gas, why is it that so much of the industry doesn't think it's necessary to monitor transformers?
There are several reasons. Number one, when you look at the solubility of the gases in oil, hydrogen solubility is very low. It wants to escape, it wants to get out of its environment.
Right.
It doesn't like to stick around. Also, when you look at sampling, as much of the data that we have is from offline monitoring, actual physical samples that are being done by a human, so you have human error in process or poor standards in practices that affect the ability to capture the entire gas profile.
Right.
In addition, when you talk about online monitoring, there are certain devices out there that require that aren't, for example, testing directly in the oil. You need an extraction. And so that can affect the ability of the device to detect all of the gases. So with, for example, solid state technology, you can measure directly in the oil. You get an accurate representation of that hydrogen gas, for example, in the dielectric fluid, which gives you a better understanding of, in some cases, the intents of the fault. There is a direct correlation between the amount of hydrogen that's being produced and the intensity of the fault.
So if you have hydrogen in a continuous measurement like you're talking about, as opposed to the fuel cell type measurements that have been there in the past, which are periodic, right? And if you can have that in there and you have temp, you have two important pieces of information.
That's right.
That you can, maybe you can't make 100% determination of what's going on, but if you have a low temperature and hydrogen beginning to rise, something's going on.
That's right.
And what would we say is going on? Partial discharge.
Right.
I mean, it may be more than that, but we can say with pretty much accuracy it's partial discharge. You don't shut a transformer down when you have partial discharge, right? You monitor. You got to see what happens next, right? So now if you were to see that and you say, well, we got partial discharge, but you begin to see a spike, lower temperature, but a spike in hydrogen, what's that telling you?
Well, it could be, various things. If you start to see a spike, if the rate of generation starts to increase, typically when you start seeing the generation increase, you're going to start seeing those other gases because temperatures are increasing inside that transformer. So you may have, overheating, sparking, arcing. And when you get to the arcing, then you're looking at the production of acetylene.
Right.
And now you're starting to reach those temperatures of 700 degrees C inside that transformer where some serious damage is being done.
Right. So you and I are both of the ilk that do the most inexpensive thing you can do to find out that there's a problem and then go out and pull a DGA sample, because we both worked for a company that did DGA sampling. Which I think the last I remember was about $65 to do a DGA sample. That's a cost-effective way to determine if there's something going on in the transformer versus a $50,000, $60,000, $70,000 monitor, correct?
Right. And think about it this way, Alan. Typically, especially with the utilities, they're not monitoring one or two transformers.
Yeah.
They're monitoring hundreds, if not thousands, of transformers in their fleet. So to have to select 20 units a year to install quite expensive equipment that after 3 to 5 years is going to require some maintenance, which is an additional cost, versus taking a single gas hydrogen monitor, installing it across the entire fleet because costs are significantly less. You get to see a bigger picture. What does the entire system look like?
Right.
Where are some of the stresses? Because when there's stress, there's gas.
Right.
And then you can go from time-based monitoring to condition-based, more predictive monitoring.
Yeah. You looked over at this. I want you to talk about this. What did you call? You mentioned that somebody in one of your distributors called this a.
Right. So I was visiting a customer in Latin America, and they referred to it as the USB stick of hydrogen monitoring. That's what they thought of.
The USB stick. What's unique about this H2scan monitor?
So this particular H2scan monitor is unique in the fact that it is solid state technology.
Okay.
Which means it doesn't require carrier gases. It doesn't require any kind of pumps because it's measuring directly in the oil.
Right.
So as the gas dissolves, it can detect that. What's also unique about it is it has an auto calibration feature. So you don't have to send a technician out there once or twice a year to recalibrate to adjust for drift or temperature. It does that on its own. In addition to that, look at it. It's so easy to install. You just put it right into the valve, communicates directly to whatever system the customer has set up, and you're done.
It's brilliant. It really is brilliant. the auto calibration tool alone is huge, because that's what a lot of people say is, I don't have the staff to go out and do this, and they don't.
Right.
And we have I know that we've talked about this, but there's a version of this that also goes in battery rooms.
That's correct.
It's area monitors. This is for transformers. I notice it says GridScan 5000. What's the 5 designation? What does that mean?
So over the years, we've developed our technology. So back in 2012, that's when we started really looking at transformer applications. Prior to that, it was all process and safety application,
right.
which we still do. But since 2012, we've started looking at how can we take our solid state hydrogen sensor and integrate it into the transformer world. So we started off with a version 3.5. Then we moved up to a version 4, and now we're at Gen 5 or GridScan 5000.
Okay, and I don't think people realize this is for direct to customer sales.
That's right.
But I don't think we're allowed to talk about who but the greatest companies in the world in this industry use this technology. Maybe
right.
not the 5000 because they're moving to it, but they use the H2scan technology in their monitors. Mm-hmm. And if we said the names of them, they would be the who's who of the industry, right?
Well, you've heard of Intel Inside?
Yeah.
We're H2scan Inside.
They just don't say it. We're going to start getting them to say it.
Right.
But the technology has been around, as you say. I got introduced to it through a company that we actually bought their monitors, mm-hmm. and then when I did a tour of their facility, I saw what made the monitor work, and I asked the guy, so who's that? And he said, that's a company called H2scan, and he was the check-in guy. Mm-hmm. And I said, oh, tell me about those. Now, the rest of the tour went on, and they're looking for me now, like, he's not allowed to talk to anybody.
He wandered off again.
He wandered off. And it turned out that when I said, tell me about the company, he said, the only company on QC that I have never rejected a product. Never.
Right.
Well, H2scan, I went back to our company and said, find out who owns H2scan. And that's how I met Dennis Reed, the founder, and the rest is history.
Well, Alan, not many people know this, but we've got over 20,000 sensors in the market. We have never had one come back because the die was defective.
20,000 in
yes.
the market. We are Intel Inside, I got to tell you. That's amazing. So we're here at Grid Edge. Mm-hmm. You've defined what Grid Edge is. Now tell me, you've got a poster presentation that you're making later on today.
Correct.
Tell me a little bit about it. You won't have the time to go through all of it, but what are you presenting?
So the title is Effectively Managing Your Transformer Fleet to Improve Reliability.
Oh, why would I not think that you would have reliability in there? Okay.
CRL.
Right. Yeah.
But the idea is that with all these challenges that we're facing and challenges that are compounding because of the direction that the world is going in, increased demand and power and increased load on our equipment. What I attempted to do in the paper is outline steps that a maintenance manager can take to improve the reliability of the assets that are already in service,
right,
and get them thinking about what they need to do when they start bringing new assets into the organization.
Right. And so I know there's, because I've seen the poster, and I know that there's like step-ups of, from
right,
the most critical all the way down to run to failure. Talk a little bit about that from a reliability perspective, because as you said, you are a certified reliability leader, as I am, so we're both reliability. But talk a little bit about those steps when you look at assets.
When you look at assets, typically what a lot of people start with is they look at, okay, which ones am I having problems with? Where are my problem child? And that could be a great point to start at, but you also need to look at what's the criticality, what's the effect if this asset goes down?
Right.
How much is that going to cost me? How's it going to affect things downstream? How's it going to affect things upstream? And when you start to evaluate what steps you need to take in order to improve the reliability of that asset, and you start to think about, having full situational awareness of everything that's affected by it,
right,
it starts to really take on a different shape. And you can really dive in and spend, hours upon hours of evaluating these assets. So taking them and identifying which units are, we'll use these terms, mission critical, for example. Which ones are critical to the system? Which ones are somewhat critical, but we can get by without it? And then which ones are, like you said, run to failure, which that even is going by the wayside with supply chain issues. I mean, we've gone from, in certain cases, certain voltages, we've gone from, 12-week lead time to over a year lead time on small transformers, small distribution transformers. I mean, I saw a figure earlier in the year that lead times across all voltage classes have increased over 400%.
Yeah. We have we're doing a panel, and one of our panel participants is the CEO of a transformer manufacturing company, not to be named, but they are a U.S. transformer manufacturer with plants in Virginia and Georgia. I just named them, right. But they open a new plant in May. We're now in April, but next month they're opening a new plant in Chihuahua, Mexico.
Right.
It's sold out for 2 years. He hadn't even opened the doors yet, and he's sold out for 2 years. It's a very good problem for him to have, but
Certainly.
a very bad problem for the industry to have, right?
Right.
And that's everywhere. And that's the newest plant in North America in the last 5 years. We just haven't been opening plants up. And you can't open them fast enough. You can expand plants, but we've had that problem. So keeping existing transformers, monitoring will not make it last longer.
Will not make it last
However,
longer.
you mentioned something, the system. We can see where the bad actors are in a system and work on them first. And if I only have a limited supply of transformers, right?
Right.
Where do I want to place them? I want to place them where they're most needed.
Exactly.
Where hydrogen says it's a problem. Excellent. Traci, thank you so much. It's always a delight to interview you.
Thank you, Alan.
Appreciate it.